Let us study about how to multiply the vectors. Multiplying a vector by a scalar of the magnitude of vector A and the absolute value of S. Its direction is the direction of vector A if S is positive. The direction is opposite if S is negative. If S is positive, then the direction is the same as the direction of vector A. So here 2 represents the absolute value that into vector A. If S is negative, then vector A, the direction is exactly opposite. Multiplying a vector by a vector. There are 2 ways to multiply a vector by a vector. One is a dot product, another one is a cross product. The first way produces a scalar quantity and it is called as a scalar product. The first way produces a scalar quantity and called as a scalar product. So the dot product of scalar quantity is a scalar product. The second way produce vector quantity is called as a vector product. Second way produces vector quantity is called as vector product. So dot product and cross product, these are the 2 types of multiplying a vector by a vector. Now let us see the first one, a scalar product. The scalar product is also called dot product. Vector A dot vector B is equal to AB cos theta. The dot product of 2 vectors, vector A and vector B, is denoted by vector A dot vector B. Dot product of 2 vectors is defined as the product of magnitude of 2 vectors and cosine of the angle between them. So theta is the angle between the 2 vectors. So we can give the examples. Work is the dot product of force and displacement. So work is the dot product of force and displacement. So vector S dot vector S, that can also be written as work done is equal to Fs cos theta. Dot product of 2 vector is a scalar quantity. Dot product of 2 vector is a scalar quantity. In the above example, the force and displacements are vectors. Their dot product work is a scalar. So here the dot product of 2 vectors is a scalar quantity. So here force and displacements are vectors. Their dot product is, that is work done, is a scalar. Hope you understood. That is a scalar product. The dot product of 2 vector is a scalar quantity. The dot product of 2 vector is a scalar quantity. We can give an example. P is equal to vector F dot vector V. P is a power, F force, V is a velocity. Here the dot product of force and velocity, both are the vector quantity. Its dot product power is a scalar quantity. So a dot product can be regarded as the product of 2 quantities. Dot product can be regarded as the product of 2 quantities. The magnitude of one of the vectors and the scalar component of the second vector along the direction of first vector. This is a geometrical meaning of a scalar or dot product. A dot product can be regarded as the product of 2 quantities. The first one, the magnitude of one of the vectors, and the second one, the scalar component of the second vectors along the direction of first vector. Geometrical meaning of scalar product. vector A dot vector B is equal to A of B cos theta. Now here, this is the diagram. It is B on A. It's a projection on B on A. The projection of vector one another vector is shown below. You can observe here. So B on A, the first one, the projection of B on A. The second one, the projection of A on B. So that can be written as vector A dot vector B is equal to A of B cos theta. So it's a projection of B on A. Second diagram, A dot B vector, that is equal to A cos theta, that into B. It is a projection of A on B. Now let us see the properties of scalar product. The scalar product is a commutative. We already studied about. Vector A dot vector B is equal to AB cos theta. So if we reverse the terms, vector B dot vector A, that is equal to BA cos theta. Therefore, vector A dot vector B is equal to vector B dot vector A. So the scalar property, the scalar product is obey the commutative law. The second one, the properties of scalar product. The scalar product is distributive over addition. The scalar product is distributive over addition. If we are having three vectors, vector A, vector B and vector C, then the distributive vector A dot vector B plus C, that is equal to vector A dot vector B plus vector A dot vector C. So the scalar product is a distributive over addition. Third one, the scalar product of two perpendicular vectors is 0. Scalar product of two perpendicular vectors is 0 because the cos 90 is, you will get the value is 0. So if the two vectors are perpendicular, then their dot product is, it comes 0. The vector A dot vector B is equal to AB cos theta. If the two vectors are perpendicular, the cos 90 value is 0. Therefore, vector A dot vector B is equal to 0. The fourth properties of scalar product. The scalar product of two parallel vectors is maximum when it is positive. So we will get a maximum value when cos theta is equal to 0. So when we will get the angle 0 if the two vectors are parallel to each other. If the two vectors are parallel to each other, you will get the maximum value. That is vector A dot vector B is equal to AB cos theta. If the two vectors are parallel, then theta is equal to 0. Cos 0 is equal to value is 1. Vector A dot vector B is equal to AB. Now let us see this fifth property. The properties of scalar product of two anti-parallel vectors is a maximum and negative. Why it is negative? Because the theta value, you have 180 degree, cos 180 is minus 1. So you will get negative value for a anti-parallel vectors. Anti-parallel vector in the sense they are in the opposite direction. The two vectors are in opposite direction. Vector A dot vector B is equal to AB cos 180 degree. So the cos 180 degree value is minus 1. Therefore, vector A dot vector B is equal to minus AB. The sixth properties of scalar product. The scalar product of vector with itself is equal to the square of its magnitude. the scalar product of a vector with itself is equal to the square of its magnitude. If it is having the we have the same vector, the both are having the same vector, vector A dot vector A, then their value you will get the square of its magnitude, that is A into A cos 0. The cos 0 value is 1, therefore you will get the A into A is A square. So the scalar product of a vector with itself, the same vector, is equal to the square of its magnitude. The seventh one, the scalar product of two same unit vector is 1 and two different unit vector is 0. So if we are having we know the three unit vectors under the x, y, z axis. So which are the three unit vectors? I cap, j cap and k cap, isn't it? The scalar product of two same unit vectors like I cap dot I cap, that is equal to j cap dot j cap, that is equal to k cap dot k cap. Its value comes 1. How it comes 1? Its magnitude is 1 and 1 each. Then cos value it becomes 0. Cos 0 is 1, so you will get the value 1. You will get the value unity. That is a scalar product of two same unit vectors. That value is 1. Two different unit vector you will get 0, because the two different vectors you will get when the angle is 90 degree. So cos 90, the value it becomes 0. The I cap dot j cap, that is equal to j cap dot k cap, that is equal to k cap dot I cap. Its value it becomes 0. Their magnitude is 1 and 1, but cos value 90 degree. Cos 90 value is 0. So you will get the value of two different unit vector is 0. Calculating scalar product using components. Now there is a two vector, vector A and vector B. Its components we have to write ax I cap plus ay j cap plus az k cap. Vector B is equal to bx I cap by j cap plus bz k cap. Now you have to find the scalar product, isn't it? So it's a vector A dot vector B. You have to multiply those components. Now you have to substitute the value of vector A into vector B. Now the ax I cap we have to multiply it with bx I cap plus by j cap plus bz k cap plus ay j cap, again it is multiplied with the components bx I cap plus by j cap plus bz k cap plus again az k cap term is multiplied with bx I cap plus by j cap plus bz k cap. You have to simplify, okay? ax into bx I dot I, okay? Similarly you have to solve the components plus ax by I dot j cap plus ax bz I dot k cap plus ay. Now ay bx j dot cap I dot cap plus ay by j dot cap plus ay bz j cap dot k cap plus az bx k cap dot I cap plus az by k cap dot j cap plus az bz k cap dot k cap. Now you know that two different unit vector, its value it becomes 0. If it is the same unit vector, its value is 1. So you'll get the I dot I1, j dot j1, k dot k1, the rest of the value it becomes 0. So you'll get the terms vector A dot vector B is equal to ax bx plus ay by plus AZ BZ. Students, you have to write this calculation in your notes, okay, so that you can understand. Now let us see the vector product. Till now we studied about scalar product. The scalar product, which is also called dot product. So the dot product and vector product, or the scalar product and vector product, these are the two different way of multiplying the vectors. The vector product is also called a cross product. Now let us see the vector product. It's a cross B vector. The cross product of two vector A and B is denoted by vector A cross vector B. Vector A cross vector B is equal to AB sin theta n cap, where theta is the angle between two vectors and n cap is the unit vector. The direction of n cap is perpendicular to the plane containing vector A and vector B. Now the vector product is defined as the product of magnitude of two vectors and sine of angle between them. So the cross product is it is defined by the sine of angle between them, whereas dot product is represented by the cosine of angle between them. The cross product of two vectors is defined as the product of magnitude of two vectors and sine of the angle between them. So vector A cross vector B is equal to AB sin theta n cap. So here that is equal to vector C. C is the cross product. Now let us see the examples of vectors. Vector product. The first one, the cross product of two vectors is always a vector. See the cross product of two vectors is always a vector. The dot product of two vectors is always a scalar quantity. But here the cross product of two vectors is always vector. The torque, it is represented by tau, is a vector product of force and radius. So here R is a position, F is a force, tau is a torque. Torque is a product of force and position that can be written as vector tau is equal to RF sin theta n cap. N cap is a unit vector. We can give one more example. Vector L is equal to vector R cross vector P, where L is the angular momentum, R is the position, P is the linear momentum. The cross product of two vectors is a vector quantity. Now, geometrical meaning of a vector product. Vector, the magnitude of vector A cross vector B is equal to A of B sin theta. Vector A cross vector B is equal to area of parallelogram made by two vectors. Vector A cross vector B is equal to A of sin theta, that into B. It depends on the projection. So the first one, it is a B sin theta. So it depends on the projection. It depends on the projection, whether it's the projection of B on A or projection of A on B. Now, the properties of vector product. We already studied about the properties of scalar product, isn't it? Now, let us see the properties of vector product. The vector product is anti-commutative. It is exactly opposite to the commutative. The commutative vector A cross vector B is equal to AB sin theta n cap. B cross A vector is equal to BA sin theta that into minus n cap. That is equal to minus AB sin theta n cap. So vector A cross B vector that is not equal to B cross into B cross into vector A. So it is anti-commutative. It is not a commutative vector. The vector product is distributive over addition. So it obeys the distributive property. If there is a 3 vector, vector A, B and C, if we are multiply the vector A into vector B plus C vector, that is equal to vector A cross vector B plus vector A cross vector C. So it obeys the distributive over addition. The magnitude of the vector product of two perpendicular vectors is maximum. So if the two vectors are perpendicular, that means the theta is equal to 90 degrees. Sin 90 value is 1. Therefore, you will get the maximum value when the two vectors are perpendicular to each other. The magnitude of vector A cross vector B is equal to AB sin 90 degree. That is equal to AB. The vector product of two parallel vector is a null vector. That means you will get the 0 value. Null in the sense 0 value. Vector A cross vector B is equal to AB sin theta. If the two vectors are parallel, then their theta it becomes 0. Sin 0 value is 0. So vector A cross vector B is equal to 0 vector. The vector product of two anti-parallel vector is also a null vector. If the two vectors are anti-parallel, that means the theta is equal to 180 degree, sin 180 value is 0. So vector A cross cross B vector, that is equal to AB sin 180 degree, that into n cap. So it becomes 0 vector. The properties of vector product. The vector product of vector with itself is a null vector. If we are multiplying with the same vector, then you will get the value is null vector, that is 0 vector. So vector A cross vector A, that is equal to A into A sin 0. Sin 0 value is 0. Therefore, you will get the value is 0. The vector product of two same vector is a null vector. If we are multiply the unit vectors, same unit vector, then you will get a null vector. I cross I cap cross I cap, that is equal to J cap cross J cap, that is equal to K cap cross K cap. Its value it becomes 0 vector or null vector. Its magnitude is 1 and 1, but the sign value is it becomes 0. Next, the vector product of two different unit vector is, you will get a third unit vector. The vector product of two different unit vector is a third unit vector. That is the case I cross I cap cross J cap, that is equal to K cap. J cross K cap, that is equal to I cap. So the two different unit vector, you will get the product is third unit vector. Okay, see I and J, it is the two different unit vector. Now we are getting the product is third unit vector, that is K cap. So in all the cases you can observe K cap cross I cap, you will get that is equal to J cap. Now if it is reverse, J cap cross I cap, that is equal to minus K cap. j cap cross I cap, that is equal to minus k cap. K cap cross j cap, that is equal to minus I cap. I cap cross k cap, that is equal to minus j cap. So here you can observe you can remember these things, aid to memory. So here I cap, j cap, k cap, it is moving in the clockwise direction. The first image, it is moving in the clockwise direction, so you are getting a positive value. I cross j cap, that value is k cap. J cap cross k cap, the value is I cap. K cross cap I cap, the value is j cap. If the values are in the anti-clockwise direction, I, j and k, it is in the anti-clockwise direction, that is j cap cross I cap, you will get the value is minus k cap. And the value I cap cross k cap, the value is minus j cap. Okay, you can remember like that. Now calculating the vector product using a component. So we already calculate the scalar product and its components, isn't it? Now we have to do the calculation of vector product using its components. Let us have the two vector A and vector B and its components. Ax I cap plus ay j cap plus az k cap. Similarly, vector B is equal to bx I cap plus by j cap plus bz k cap. Then vector A cross vector B, that is equal to, you have to multiply those components. Now vector A cross vector B. Now you have to multiply the each components. Ax I cap, that into bx I cap plus by j cap plus bz k cap plus ay j cap into bx I cap plus by j cap plus bz k cap plus az k cap, that into bx I cap plus by j cap plus bz k cap, that is equal to, you have to multiply the component ax bx I cap cross I cap plus ax by I cap cross j cap plus ax bz I cap cross k cap plus ay bx j cap cross I cap plus ay by j cap cross j cap plus ay bz j cap cross k cap plus az bx k cap cross I cap plus az by k cap cross j cap plus az bz k cap cross k cap. Now if it is a same unit vector, then the value it becomes 0. If it is a different unit vector, then you will get the third vector. So the first I cap cross I cap 0, I cap cross j cap, the value is k cap, I cap cross k cap, the value is minus j cap, j cap cross I cap, the value is minus k cap, j cap cross j cap, the value it becomes 0, j cap cross k cap, the value is I, k cap cross I cap, the value is j cap, k cap cross j cap, the value is minus I, and k cap cross k cap, the value it becomes 0, and you have to write those values. Therefore you will get the value A cross vector B is equal to I cap ay bz minus az by, that minus j cap, that into ax bz minus az bx plus k cap terms ax by minus ay bx. That can also be written in this order: I cap, j cap, k cap. You have to write the terms, that is ax ay az determinant I cap, j cap, k cap. So we have to write the terms ax ay az bx by bz. So vector A cross vector B is equal to determinant of these values I cap, j cap, k cap and their values ax, ay, az, bx, by, bz. Students, you have to go through the video twice to understand the concept. It's very important to know about the scalars and vectors. Once you know the concept properly, thoroughly, then you will get to know the in future concepts. Okay, where every time we are using these concepts. Okay, that time I'm not going to repeat the properties and again. So you have to go through the scalar and vector video thoroughly. So you must try to understand the concept. That is very important. I know some of you studied in your in your high school, but still you have to go through the videos twice. Okay, thank you dear students.